Find the derivative of y equals the square root of sine t, then evaluate y prime of pi over 2. Y here is made up of the root of an entire expression sine of t. The first thing I'm going to do is rewrite the root as a fractional exponent. The sine of t is to the first power, and then second or square root, so 1/2 power. The derivative, y prime, which can also be called dy dt, will start with the outermost function, which is the 1/2 power, which follows the power rule. So we're going to bring the 1/2 down. You leave the entire inside alone. Subtract 1 from the 1/2, so minus, I will call it 2 over 2. But because what's raised to the power isn't just a t, but an entire expression, sine of t, we have to take the derivative of the inside to complete the chain rule. Derivative of sine of t is cosine of t. So we have a 1/2, we have a sine of t to the 1 minus 2, which is negative 1/2, and we have a cosine of t. Since we have a negative exponent here, I'm going to move that to the denominator, which will move down to where the 2 is from the 1/2, and it'll be a positive 1/2 power. The numerator will be a 1 and a cosine of t. These do not have negative exponents on them, will stay in the numerator. 1 times cosine of t will be cosine of t. So our y prime, or our dy dt, will be cosine of t over 2 times the sine of t to the positive 1/2, and we move it down there to be positive with the 2. Positive 1/2 power means first power, second root, or square root of sine of t to the first power, so square root of sine t. And there's our derivative y prime, or dy dt. Our next step is to evaluate y prime of pi over 2. So let's plug a pi over 2 in for each of our t's. That will give us a cosine of pi over 2 divided by 2 times the square root of sine of pi over 2. The cosine of pi over 2 is a 0. The sine of pi over 2 is a 1. And we'll have 0 over 2 times the square root of 1. Square root of 1 is 1 times 2 is 2. 0 over any non-zero number equals to 0. So y prime of pi over 2 will be a 0.